Hello guys, welcome back to TechDose, and in this video we will see the My Calendar 2 problem, which is from Leetcode number 731, and we will be seeing the optimal line sweep algorithm here. And one similar problem which you can watch after having completed this video would be to see the minimum platforms needed in a railway station problem. So let us now look at the problem statement. In this problem, you are implementing a program to use your calendar. We can add a new event if adding the event will not cause a triple booking. A triple booking happens when three events have some non-empty intersection, that is, some moment is common to all the three events. The event can be represented as a pair of integers start and end that represents a booking on the half open interval start comma end, where start is included and the end point is not included in the range. And this is represented as start is less than equals to x and x is less than end. Implement the myCalendar2 class, where myCalendar2 will be just an initializer of the object, so it is the constructor, and you have to write the boolean API which will take the start and end of an interval, and we need to return true if the event can be added to the calendar successfully without causing a triple booking. Otherwise we need to return false, that the booking is not possible. Okay, so let us now look at an example for better understanding. Let's say that we are given these intervals. Now this will act just like an online algorithm. As I had explained in my calendar 1, this will work as an online algorithm. So the entire interval set is not given to you initially. One interval will come at a time. Okay, so first interval is, let's say, 10,20. When you see 10,20, you don't have any booking right now. So definitely if you get the interval 10,20, you need to return true for this. And you need to save that, okay, this range has been booked, 10,20 has been booked. Let's say the next call which is coming is for 50,60. Now you will be matching with all the bookings already done and check out, is it overlapping? And if it is overlapping, then what is the overlap count? Is it 1 or 2? So you see that 50 and 60 is not overlapping with the already done booking, which is 1020, and therefore I need to return true here. I need to remember this. I need to save it somewhere, right? Let's say the third item which is coming is 10,40. So when 10,40 comes, then you need to check with the previous two bookings done. That means 10,20 and 50,60. Yes, it is overlapping with 10,20, so there is one overlap. But 50,60 is not overlapping, and therefore the count of total overlap is only 1. And since one overlap is allowed, and therefore I will be returning true here and save this 10,40 in the range. Now let's say the next request which is coming is 515. Now when the 515 comes, I will be checking with all the bookings already done with 10,20. It is overlapping, right? So you see that I have made hollow sphere at the end because this is not included, and the solid sphere means this is included. So when I say 10,20, it is 10 inclusive and 20 is not included, right? So compare this 5 with 15. 10 to less than 15 is overlapping, so count of overlap is 1. 50,60 is not overlapping. 10,40 is again overlapping from 10 to less than 15, so count of overlap is 2. So when the overlap count is more than 1, then this will not be allowed. So that is why you return false, and since you have returned false for this, you don't need to save it. Okay, no need to save it because the booking was not done. Now for 5,10, if this booking is coming, then again you have to do the same process. With 1020 it is not overlapping because this is inclusive and this is not included, so no overlap. With 5060 no overlap. With 1040 as well no overlap, so you need to return true. Again for 2555, compare it with 1020, it is not overlapping. With 5060 it is overlapping in between 50 to less than 55, so count of overlap is 1. With 10 to 40, again it is overlapping, which is from 25 to 40, right? But then I cannot increase the count of overlap by 1 because this range is different. This range is from 25 to less than 40. This range is from 50 to less than 55. So since these intervals are different, therefore there is count 1 in this interval and the count equals to 1 in the other interval, right? And then 5,15 is not even present in our set, and 5,10 is not overlapping, so this booking will also be allowed. Whenever I say that triple booking is not allowed, then the count should be 2 for that particular interval itself. Now let us look at how to check for the overlaps. So in the overlap check, the first 4 type of overlaps I have drawn in the figure, right? So if the red one is S1 E1 and the yellow one is S2 E2. So if S2 lies in between S1 E1, or E2 lies in between S1 and E1, then there will be an overlap. So the 4 cases I have drawn. If you notice in these 4 cases, then you will find that the maximum of S1 and S2 will always be less than the minimum of E1 and E2. In all the 4 cases, that will be true. Okay, so if this condition happens, that the maximum of S1 comma S2 is less than minimum of E1 comma E2, then the two intervals will be overlapping, otherwise they will not overlap. So these are the non-overlapping cases. In this case, you check that the maximum of S1 and S2 is S2 and the minimum of E1 and E2 is E1. So S2 is S2 less than E1? No. So there is no overlap. And similarly, the maximum of S2 and S1 is S1 and the minimum of E1 and E2 is E2. So is S1 less than E2? No. So that is why there is no overlap, right? So this is just a simple condition for you to apply the overlap check. Now let's see the simple approach. In the simple approach, what we can do is we have to just iterate for all the intervals. So let's do that. I will explain you why we have taken overlap 1 and 2. Let's see this 10 comma 20. The overlap 1 will say that there is an overlap. There is at least one overlap. Okay. So 10 comma 20, when it comes, the array is empty. So we need to just insert it into the array and say that we can actually book this 10 to 20. Okay. Now let's say the next interval coming is 50 to 60. Now we have to iterate over all the overlap intervals 1 and see that is there any overlap. You see that there will be no overlap. Okay, if 50 comma 60 compared with 10 comma 20, there will be no overlap. So 50 comma 60 is pushed here. So we will be returning true in this case. Again for 10 comma 40, if you check it with all the bookings already done, then you will see that with 10 comma 20 there is an overlap between 10 and 40. So if there is one time overlap, we can also have 2 times overlap. How do we know there is no 2 time overlap? So for the 2 time overlap, we will be maintaining another array which will only be storing the intervals where there is more than one overlap. That means where there is 2 overlap, to be frank. So in this case, I will be iterating through all the items of overlap 2, but there is no item. That means there has been no 2 overlaps seen yet, right? So what we will do is we will insert this 10 comma 40 into the overlap 1, and then we will be taking the common part between 1040 and 1020. Like I have drawn here 1020 and 1040. If you take the overlap, then definitely some part of it will have the overlap, right? So it will be the maximum of S1 and S2 and the minimum of E1 and E2. That will be the range of overlap. So the maximum of 10 and 10 is 10 and the minimum of 20 and 40 is 20. This I had already explained according to this diagram, right? So I think you have understood it already. So this range indicates that there is a double overlap in the range of 10 to 20. Okay, and we will be returning true because double overlap is allowed. Let's see for 5 comma 15. If you take 5 comma 15 and we have to iterate for all the items in overlap 1, the first item itself is matching, and here it is saying that okay, there is an overlap from 10 to less than 15. Now if there is one time overlap, then there can be 2 times overlap as well. So we will go to overlap 2 array and then we will check for all the items in overlap 2. We will be checking is there any overlap. If there is an overlap, then we will be doing a triple booking if we allow this to happen. So this is not allowed, right? In this case 10 comma 20 will be compared with 5 comma 15, and yes, there is an overlap from 10 to less than 15, and that is why this cannot be allowed and we have to return false here, right? So since this booking was not done, the entry of it will not be inserted in either of overlap 1 or overlap 2. So this is the simplest approach where we will be saving all the intervals in overlap 1 and overlap 2. Now if you see this, then the overlap 1 is talking about the intervals ranges where there is at least one overlap, and overlap 2 is talking about the interval ranges in which there is a double overlap, right? So if we had to even maintain a triple overlap, like if there was a follow-up question, then I will be saving it in overlap 3. If it was having k number of overlaps, I will be storing in overlap number k as well. So we will be needing k number of arrays, and we will be matching it k times as well, right? So that is why this is not an optimal approach. But then just coming to the problem statement, we just had double overlap. and triple was not allowed. Therefore, now since we are iterating through the entire array one time and then checking it into the overlap 1 and overlap 2, so for each interval we will be doing order of n operation, and that is why the time complexity is n square. This space complexity is order of n because in this case we will be having maximum size of the array will be 2n, right? And that is why it is order of n. Now let's look at an idea in order to solve this problem optimally. So I have taken a taxi route, and the taxi route starts at A and ends at G. Okay. Now the taxi has maximum of 2 seats, and these are the people who are coming one by one. Okay. Now let's say if person P1 comes into the taxi to take the taxi, then definitely if the seats are available, then only P1 will be scheduled. Now I will say a variable is C, where it will say how many seats are consumed, and it is 0. So if seats consumed are greater than equals to the maximum seats, then definitely you cannot allot more seats, right? So if P1 is coming, then you see that the C is less than the maximum seat, so P1 can get into the taxi, and so consumed seats will become 1 and P1 can get in. Now if P2 comes in at A again and then he wants to get out at E, so can he get in? Yes, because C is less than maximum seat, so it can consume the seat, and then P2 will also be scheduled, right? So we have already been booked for a range of A to C and also for a range of A to E. You look at the route, right? So P1 gets in here and P1 will get out at this point, and P2 has got in here and P2 will get out at E, right? So this is the current scenario. Now when the taxi starts moving and it reaches B, then there is a person P3 who is coming to consume the seat. Now is the seat available? You see that the consumed seat is 2, which is equals to maximum seat, so he will not be allowed to consume the seat. Now the taxi will move to C, and let's say again somebody like P4 wants to get into the taxi. Now if you have ever noticed in the public transport, if the transport stops, then we always prefer those guys first who wants to get out of the transport, so that space is vacated and then people will start getting into the taxi or bus or whatever, right? So in this case, if I first calculate that, okay, can P4 get into the taxi, there is no space, but then I will let the others, whoever want to come out of the taxi, come out. So who wants to come out? P1 wants to come out, so P1 will get out of the taxi and P4 will get into the taxi and he will be vacating at F, right? So getting out of the taxi makes the consumed number of seat as 1, and since P4 is getting in, it will again be 2, right? After this we will be reaching to, let's say, D, and at point D, so P4 was allowed, by the way. So at point T, you see that P5 is coming in, but will he be given the seat? You see who are the ones who are being in the taxi? P4 and you have P2. Now P2 is coming out at E and P4 is coming out at F. So at D, seat will not be allotted to P5. Okay. And what happens to P6? When you go to E, then again P2 will get out. So P2 gets out, so the consumed seats will become 1. So P6 will be allotted. So P6 can get in here and P6 will be getting out at G. So P6 will also be allotted seat. So this is a day-to-day general strategy which everyone knows, right? And we will be applying this to solve our entire solution. Now in this strategy, everyone must have understood the idea because you have been saying this in the daily life. But then how to algorithmically solve this? How to keep track of who are the ones who are present in the taxi, or I mean, if I want to say that in any interval, like whenever I say that somebody is traveling from a source to a destination, it is as good as saying that this is an interval it is covering. When I say that P2 is traveling from A to, let's say, E, then this is the interval it is covering, right? Now we cannot have more than 2 overlaps in the interval because the maximum seats are 2. If I increase these maximum seats to 3, then I cannot have more than 3 overlaps in any kind of route, okay, in any kind of person's destination, source to destination. So this problem is the same as the one which is given already, right? That we should not exceed the maximum number of seats. Now in this case, we can track how many people are actually sitting at any point of time. I will again do the dry run of the same thing. Now let's see how to implement our idea using an algorithm. So what we will do is whenever a person is coming, we will just assign him a seat. And after every assignment, I will be checking if the total number of assigned seats exceed the maximum number of seats. That means that person's assignment is incorrect and we will not assign him the seat. So let me show you how this idea works. So I will be taking a seats array. Let's say a seat assignment array, right? and initially none of the people have been assigned the seat, so all these stations will have 0 assigned seat. Okay, so these are the stops. Now let's say the taxi was at A and then person 1 comes at A. Now he wants to go to C. What I will do is I will assign him the seat, and once I assign him the seat, I will be adding one seat at A, and since he will be getting out at C, I will be subtracting one seat at C, because at C one more seat will be available, right? After the assignment has been done, I will be iterating through all the stops, and I will be calculating what will be the maximum number of seats needed at any point of time. So if I iterate, I will have a counter equals to 0. Now at A I need 1 seat, at B I need 0 seat, at C the seat will be vacated, 1 seat will be vacated, that is why there is a -1. I will subtract and it becomes 0. At D 0 seats are needed, so it will be 0. At E 0 seats are needed, F 0 seats are needed, and at G as well 0 seats are needed. So the total peak, like what we are seeing is we are finding the peak. Now the peak here is 1 only, right? And that is why we need maximum of 1 seat at any given point of time. That means P1 will be assigned the seat. Now let's think about P2. When P2 comes in, he will want the seat at A. So he wants to get in at A, let him get the seat. So if we assign him, then at A we need one more seat, and at E since he will be coming out, so we will do -1 at E, right? We will be subtracting one value at E. Now let's check if this is a proper assignment. So what we will do is we will be iterating through all these stops, and we will have a counter again starting from 0. We need 2 seats at A, so this will be 2. Did we go above the maximum seats? No. If we at any point of time go above the maximum seats, then that means this assignment is incorrect. Now we need 0 seats at B, so 0 will be added, -1 will be added, so this becomes 1, 0 added, -1 added, it becomes 0, 0 added, and 0 added. So that means we need maximum of 2 seats, which is less than equals to max seats, so this is also assigned the seat. Now let's think about P3. When P3 comes in, he will need the seat at B, so we will do +1 at B, and he will come out at D, so we will do -1 at D. Okay. Now if this is the case, then we will again repeat the process and check what is the peak seats that we need. So we will go from left to right and keep counting how many seats we need at any given point of time. At A we need 2 seats, so we will add 2 seats. Is 2 less than equals to max seat? Yes. At B I will need one more seat, so we will need 3 seats now. Is this 3 less than equals to 3? No. So that means this assignment is incorrect. P3 will not be assigned the seat, and that is why since P3 does not get the seat, we will add 1 to this. It becomes 0, and it will not be coming in at B, so we will do -1 here just to revert back the state, and this becomes 0. Similarly, now P4 will be coming, and then he will come in at C, so we will assign him the seat. It becomes 0, and he will come out at F, so this becomes -1. Now again check the assignment, make the counter as 0, go from left to right and find the cumulative sum. And if at any given point of time max seats are greater than 2, that means it cannot be assigned. So see, the initial value is 2, 2 is added, then 0, 0 is added, then 0, 0 is added, then -1, so this becomes 1, then a 0, again 0 is added, -1, so it will become 0. So we did not exceed the value 2 at any point, that means P4 will get the seat assignment. After this, let's say P5 is coming, he will try to come in at E and wants to get out at G. So if he comes in at E, then he will need 1 seat at E, and want to get out at G, he will be leaving the seat. Now again repeat the process and check the peak count. So initially at A we need 2 seat, B we do not need any seat, C we do not need any seat, at D 1 effective seat is vacated, so we have total 1 count. At E 1 seat is needed, 2 count. At F 1 seat is vacated, so 1 count. At G 1 seat is vacated, so 0 count. So we did not exceed the value 2. So P5 will also get the assignment. Similarly repeat for P6. P6 is coming in at D and going out at F. So at D we will increment the counter by 1, this becomes 0. And at F we will do -1, so this becomes -2. Now again find the peak count. So initially it will start at 0. At A we need 2 seats. At B we need 0 seats. At C we need 0 seat. At D 0. At E we need one more seat, which is 3 seat. So 3 is more than 2, and that is why this assignment is not allowed. And we will revert back the state of D and F. So we will add 1 to F because 1 was subtracted, so this becomes -1. At D we will be subtracting one value, so this becomes -1 as well. So this is the process by which we will be finding out who will be assigned the seat and who will not get the seat. In this technique we are moving from one direction to the other. which is like as if we are assuming a vertical line and we are moving the line from left to right, just like we are sweeping it. And since we are doing it in one dimensional, that is why it is called a line sweep algorithm. Okay, so this is line sweep 1D. We will use this algorithm to solve the problem optimally. After the exact solution of this problem, at the end I will discuss about why this line sweep is better than the first approach. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. Now I will be applying the previous technique into our problem, and we are given an intervals array, and I will be taking an ordered map, so it will be ordered based on the key. The key will all be the starting and the ending point of the interval, and the count will be how many overlaps is it happening, right? So let's take a look at the first interval. The first interval starts at 10. What I will do is I will iterate through the entire map and count how many overlaps are happening in between the range of 10 and 20. So what I will do is first I will insert this interval. So let's say that I inserted 10 with a count of 1, and since I want to get out at 20, I will insert 20 with a -1. Like the similar way how we were getting into the taxi, I was saying that one more seat is consumed, and when we were getting out, one seat is vacant, right? So that is why we were doing +1 while getting in and -1 while getting out. The interval is also starting at some point, so we do +1 wherever it is starting, and when it is ending we are doing -1. That an overlap is ending here, right? So in this case, what I will do is first I will input this interval into the map, and then I will count for the overlaps. So if I count for the overlap, then I will keep a counter equals to 0 initially, and when I reach to 10, my count becomes 1, and when I reach to 20, my count becomes 0. So at any point of time, if the value increases beyond 2, then that means there is triple overlap, right? And that is why I will say that the interval is not allowed. But in this case, there is no triple overlap, so this is allowed. Now for the next interval 50-60. The first thing I will do is let's insert 50-60. So an interval starting at 50, so I'll do +1 at 50. An interval ending at 60, so I will do -1 at 60. This is an ordered map, so that is why I'm keeping the keys ordered. Once you have done this entry, I have to iterate through this entire map and check the count value, track the count value. So the count value will start at 0. At 10 it is incremented because an interval is starting. At 20 the interval is ending, so this becomes 0. At 50 an interval is starting, add 1 to it, and at 60 the interval is ending, it will be -1, so it becomes 0. So at any point of time we did not exceed the value 2, and that is why this is also allowed return true. Same thing we will do for 10-40. For this number I will be inserting first the interval 10-40 into the map. So if I insert 10-40, 10's value will increase by 1, this becomes 2, 40 will be inserted here, and this becomes -1. Okay, so the interval is ending at 40. Now I will again iterate through the map and keep incrementing the counter. So at 2 the counter starts at 0, so at 10 it becomes 2. Now at 20 it is -1, so it becomes 1. At 40 it becomes -1, so this becomes 0. At 50 there is a 1, so this becomes 1. At 60 there is a -1, so this becomes 0. At any point of time we did not have a triple overlap because we did not exceed value 2, so this is also allowed. Let's look at the next one, which is 5-15. If you look at it, first I will insert 5-15 into the map. So 5 will be inserted with a value 1 and 15 will be inserted with a value -1. Okay, again repeat the same process going top down. When you repeat the process, then we will keep a counter equals to 0. At 5 we will do +1, at 10 we will do +2, and this becomes 3. So as soon as you exceed a value 2, that means there is a triple overlap, right? So that is why this interval will not be allowed. We have to return false here, but before returning false I will be decrementing the counter of this 0 and 0. I'll make this 0, I'll make this 0, right? So it is like I had incremented the counter at 5, so I will decrement it, and I had decremented the counter at 15, so I will increment it, because other intervals might have been starting at this point, right? And if the value becomes 0, that means this interval is no more needed, and I will be removing it from the map itself. Okay, so that in future I don't have to do any unnecessary iterations. Again, we will be checking for 5 comma 10. So I will be inserting an entry 5 with 1, and in entry 10 I will do -1. So this becomes 1. Now I will check the validity of this insertion. So I will again go top down and keep a counter equals to 0. At 5 we have value 1, so add 1. At 10 we have value 1, add 1. At 20 we have value -1, it will be 1. At 40 we have -1, it is 0. At 50 it is 1, so this will be 1. At 60 it is -1, so this will be 0. At any point of time we did not find a value greater than 2, so this is also allowed. We will be returning true in this case. So this is the technique of applying the line sweep 1D using an ordered map. Okay, now if you look at it carefully, we can have a total of order of n number of entries for n number of intervals, and for every interval that we are about to check, we might have to iterate for the entire map, right? So that can be done in like order of n time, and any insertion or erasing can be order of log n, right? So just keeping things simple, this would be for every interval I have to check for the entire map, and that is why this can be order of n square technique, right? And the space complexity is order of n because of the map containing all the intervals in the worst case. Why did I say that this approach is more optimal? Because even if you increase the requirement from double overlapping to triple overlapping or 10 times overlapping, k overlapping, it can be solved by just adjusting the counter value and with a single map. But if you had used the first approach, even though it is n square, but it is n square and order of n space complexity only when it is a double overlap. But if it is k times overlap, you have to take k times array. So the space complexity will be nk and the time complexity will also be very high. Okay, so this is a optimal approach in this case. Let us now look at the code implementation. This is my code for the problem where I have taken stops as global in the class, and then in the main constructor I have not given anything. In the booking function, first I will take the interval start comma end s comma e, and I will be adding +1 value in the map, and I will be decrementing at the endpoint. So first I will be inserting the interval as I had shown in the dry run. Then I will be having a booking counter, which was the counter which I had taken starting with 0, that is booked here. Okay, I will be iterating through all the entries of the map, all the KB pairs, and if the value ever exceeds 2, then that means this interval cannot be allowed. And since we had incremented a value 1 at the start, I will be decrementing it, and since I had decremented the value at end, I will be incrementing it. Okay, so I'm reverting back, and if after reverting back the entries have 0 values, then I will be removing that unnecessary entry as I had explained, and I will be returning false. Otherwise, if the booking never exceeded 2, then I will be returning true, and I will be keeping the entry saved in the map. So this is the entire order of n square approach. I hope you were able to understand this. If you have any problem, then do comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.